In this section, we'll explain the machine learning algorithm through a few case studies. Assume that there is a dataset containing of house areas and house prices that are sold in a city. Based on this data, we can predict the prices of another houses in other cities or the same city. This case contains a large amount of data, including house area X and output price Y. We can use the regression of supervised learning to solve this problem. Our objective is to build a model or model function h of x that approximates the function that can express the true distribution of the dataset. The model function h of x is used to predict the price of an unknown house, and that's the goal here. We use linear regression to build the model. The objective is to find a straight line that best fits the dataset. Here, we need to learn the parameters W0, W1. The best model is to find out when the two parameters are determined. To determine the optimal parameter, we can first define a loss function and find the parameter values that yield the minimum loss function value. We can use gradient descent to find the minimum value of the loss function. The gradient descent starts from a randomly initialized point and then iteratively moves towards the global minimum value of the loss function based on the negative gradient direction. This figure shows an illustrative example of gradient descent. The point A is the position of W0 and W1 after random initialization. The connection A to B is a track formed based on the descent in a negative gradient direction. Upon each descent, values W0 and W1 change, and the regression line also changes. Point B is the global minimum of the loss function. When point B is found by the algorithm, the best values of W0 and W1 are found. These figures are illustrative examples of descent iteration. It can be seen that as red dot on the loss function gradually moves to the lowest point, fitting of the linear regression red line with data becomes better and better. At this time, we can get the best parameters. When the model is trained, we can use the test samples to validate the effectiveness of the model. If the model overfits the data, we can apply lasso regression or ridge regression with regular terms and tune the hyperparameters. If the model underfits the data, we can apply a more complex regression model such as GBDT. Here, we can summarize the content of this section. First, this section describes the definition and classification of machine learning, as well as problems machine learning solves. Then it introduces key knowledge points of machine learning, including the overall procedure, such as data collection, data cleansing, feature extraction, model training, and evaluation, and model deployment at the last. Common algorithms such as linear regression, logistic regression, decision tree, SVM, naive Bayes, KNN, ensemble learning, k-means, etc. Gradient descent algorithm, and hyperparameters. Finally, a complete machine learning process is presented by a case study of using linear regression to predict house prices. And this is the end of this chapter. Thank you for watching and see you next time.